Hi guys! Okay, so we're on week 8 already. Can you believe it? So we're going to do chapter 27. It's going to be pretty brief because a lot of it's anatomy and physiology. I'm not sure if you've gone over it yet in A&P. However, it's just a matter of memorizing and understanding concepts. So I'll just point out the important things that I want you to know, and then obviously take the time to learn it on your own. Okay, great. Chapter 27, the urinary system, page 314, 314. Okay, so what is the urinary system? Basically, it's everything that goes on with peeing, voiding. Quick thing though, I never knew this. The very beginning of the chapter, it goes, when combined, so the urinary system, when combined with the male reproductive system, it is known as the genitourinary system. I totally thought that applied to females as well. Everything that I've ever known and done in the hospital does. So I don't know what that means, and I looked it up and I couldn't find anything. So anyways, genitourinary system goes both ways when you're doing charting. Okay, so what is the structure and the function of the urinary system? The major structures of the urinary system are 2 kidneys, extract waste from the blood, balance body fluids and form urine. 2 ureters conduct urine from the kidneys to the urinary bladder. So you got your kidneys, you got your ureter, and then you have the urinary bladder, a nice little ball, serves as the reservoir for urine, and then the urethra conducts urine from the bladder to the outside of the body for elimination. Awesome. You know those functions? That's the urinary system. Okay, so the urinary system helps also control blood volume by excreting or conserving water. And this is going to go back to the RAAA system that we've learned before. And I'm pretty sure there's a page that we go over with it again. Okay, so what are the kidneys? The kidneys, about the size of a human fist. They sit in the back. It's like the flank area, I guess you could say. Just easier to Google it. They are not part of the peritoneal cavity. They're retroperitoneal, which means behind the peritoneum. So, test question, what's inside the peritoneum? Look that up. The kidneys are not, okay? They also have what is called the adrenal gland, which is right on top of each kidney, and these influence blood pressure as well as sodium and water retention in the kidneys. Awesome. Okay, so what's really cool though is that when they do any sort of surgery in the kidney, like the book points out, they just go from the back or whatever, and they don't even have to go enter any sort of abdominal area. They just go right behind. Another thing, they are extremely vascular. So how we were talking about the liver being super vascular, so are the kidneys. If you get hit in the back, if anything goes on, it's gonna bleed, internal bleeding, and only the shock. Lack of circulating volume. Okay, so not only are they vascular, they can precisely regulate and adjust electrolyte levels. Body fluid volume is regulated by management of sodium chloride. The kidneys balance pH in the blood, the body fluids, and within body tissues by eliminating acids directly into the urine or by excreting acids bound to chemical buffers. These buffers change strong acids into weaker acids, enabling the kidneys to excrete large amounts of acid without dramatically altering or lowering urine pH. However, urine is still 1,000 times more acidic than blood. And what's the blood pH? Perfect balance is 7.4, in between 7.35 to 7.45. Other major functions of the kidneys include hormonal secretion of renin and erythropoietin and activation of vitamin D. So, this next little special consideration talks about nutrition. Basically, it says depending on what you eat, it has a huge impact on your urine. Like asparagus makes your pee stink. So, also, I guess eating like cranberries, meat, and high protein diet food makes your urine super acidic, which makes your body acidic, which makes you more susceptible to viruses and bacteria and getting sick. So it's better to have an alkaline body, which you can get from citrus fruits, despite them being acidic. Dairy products, I guess, can make your body alkaline, and legumes. Beans, eat them. Okay, so blah, blah, blah. Next, I'm going to skip down to the nephrons on the bottom of page 315. The kidney's major role is the filtration of water-soluble wastes out of the blood. Nephrons are the functional units of the kidney. Nephrons form urine. Nephrons form urine. The other structures of the urinary system expel urine. So the nephrons are the big guys when it comes to forming urine. So there's more than 1 million microscopic nephrons on each kidney. But this is pretty cool. Humans can survive using only 1/3 of their nephrons. That's super cool. So if there's kidney damage, you can still survive. Your body is amazing. Okay, so then it's going to talk a lot about all that kind of stuff on page 316. Lots of anatomy, physiology, lots of physiology to understand things, how they work. So, but I want you to know though, when it comes to critically thinking, okay, so your nephrons, your kidneys filter your blood, right? Nephrons form urine. When that's not happening, what's happening in the body? What's going on? Things are getting backed up, things aren't working right. So, there's several disease processes such as glomerulonephritis, which we'll talk about later, and diabetic nephropathy can cause alteration in the basement membrane, thereby reducing the filtering ability of the kidneys. It's all about a filter. You got to filter things out. So if the filter's not working, then it's not going to get excreted. Okay, so blah, 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 blah. So on page 317, the whole right column paragraph is super good to know. I'm going to just read the beginning of it, but I want you to really look at page 317's right column, okay? So the first portion, okay, so extending from Bowman's capsule, so that's part of the nephron, is a long twisted tube, the convoluted tube, consisting of freely permeable cell membranes. The first portion is the proximal convoluted tubule. Here, glucose, amino acids, and salts, electrolytes, are actively transported across membranes and returned to the blood. And then talks about all good stuff. I'm not going to read it to you. Look at page 317. So basically, and then it's really cool. They have little tables here. The tables in the, what are they called again? Like important points or key concepts. Look at those. Know those. Super good. So the nephron structures and their functions. It talks about all of those little things. Super good to know, okay? Because then it just keeps in play with the RAA system. Okay, so page 318, key concept. The pathway of the urine in the kidney. Take a look at that. Understand that. Know that. They also have the renin and the RAA mechanism. And we talked about this page before. What was that, like week 2 or something like that? So take a look at it again and understand how the function works. And there's a beautiful little diagram right there. Page 318, understand how the RAA system goes and kind of keep that into memory. So, erythropoietin, I'm on page 318. The second hormone produced by the kidneys, so you have renin is the first, and the second one is erythropoietin. This hormone stimulates the stem cells and red bone marrow to increase formation of red blood cells. This is known as erythropoiesis. So EPO, erythropoietin, is secreted when hypoxia is recognized, usually the result of injury or cardiac or pulmonary disorder. So this is really interesting, this nursing alert. And so in chronic renal failure, so chronic kidney failure, the kidneys do not function properly, resulting in inadequate erythropoietin production, usually resulting in anemia because it's not stimulating your bone marrow to produce red blood cells. So there's what's called synthetic erythropoietin, which is epoetin alpha, is often given to alleviate this anemia. So if they have kidney damage, they're going to be given epoetin alpha. This is on page 318, the nursing alert. Super good to just understand and just like think things through. So also vitamin D, if you have kidney failure, you have to give vitamin D actively because the inactive form is diet and sunlight. Oh, I'm sorry. So the active form, so give the active form vitamin D because the inactive form is usually from sunlight, isn't going to be absorbed the same way because the kidneys help synthesize vitamin D, but if they're damaged, they're not going to do a great job synthesizing it in your body, so you have to give more of a supplementation form. Okay, renal blood flow. So this is also just understanding the anatomy and physiology. I'm not going to go into it, but take a look at your book and understand how it's going. So the kidneys receive their generous blood supply from the renal arteries, and because they branch directly from the abdominal aorta, renal blood is highly oxygenated. So that's an important thing I want you to know, is that they get their blood flow from the abdominal aorta, which is highly oxygenated. Awesome, so fresh blood is going right in there to get filtered through. So, key concept, Functions of the kidneys. So waste removal, regulation of electrolytes by excretion and reabsorption, particularly sodium, potassium, and calcium, secretion of specific hormones, renin and erythropoietin, maintenance of acid-base, fluid, and electrolyte balance, the RAA cycle, conversion of vitamin D to a useful form. Awesome. You know those? You can critically think through any sort of kidney failure or kidney issue going on in your patient. So the organs of the storage and elimination. So again, you have your kidneys, you have your ureters, little tubules that connect, and then you have your bladder. Your bladder is a nice little ball that holds all that urine in there. Apparently you can hold up to about 1,000 milliliters. Oh my gosh, I've had somebody that couldn't pee. I did a Foley catheter. I think he got out like almost 2,000. But you have to be careful with that. So quick thing, if you get out too much urine at once, you can cause a bladder spasm, and that can be super painful and just not a good thing for the patient. So if you know they have a very full bladder, empty it, 500, wait like a minute or 5 or so. I don't really know exactly how much time. Empty the next amount of like 500, wait, then empty another 500, then wait, then like so on, so on. So just like give your patient a break when it comes to emptying the bladder. Okay, anyways though, so it's very hollow. Just know though that the, so it's like right below, obviously when you put pressure somewhere and you feel like you have to pee, that's when you know where the bladder is. Okay, so let's see here. So when the bladder is full, it can extend up into the abdominal cavity. The bladder capacity varies. So around 200 to 400 mils is when you're going to start feeling the need to go to the bathroom. So about every 2 to 5 hours. To initiate urination, the detrusor muscle contracts and the external sphincter relaxes. The external sphincter is what you can control to hold your pee in. So just as long as everything's relaxed, it's gonna flow. So that's when they like try to have you just be super relaxed when you're trying to pee. So also just know when it comes to children and voluntary voiding, they can't really like control that until about 18 to 24 months. So by that time, just hang out and wait. Okay, so then you have the urethra. So the men's urethra is about 8 inches long from the bladder to the very tip. The woman's 1.5 inches. Awesome. So that's why it's so frustrating for women, because well, you don't have much room to like hold that much more pee or to hold that in. So that's what that's going on. And then so when it comes to Foley's, that's why there's different lengths. So make sure when you have a men that you're getting like a long size, because you have 8 inches of urethra just to get to the bladder. Whereas women, you can just do like a tiny little straight cath and the tube is like that long. Just get in there, boop, and you got the sample. Okay, so then there's the blood pressure regulation. That again goes with the RAA system, the renin, the ADH, the angiotensin, everything like that. So make sure, I want to read this paragraph to you, but I'm not going to. So page 320, blood pressure regulation. Just know it all plays into there. So you have about urine formation now. So normally about 750 to 2,000 mils of urine is formed daily. So that's about 31 to 83 mils per hour. So as long as you know your patient is voiding about that much per hour, give or take, then you know that they're adequately filtering out their body, like their kidney function is good. If it's less than that, you got to think, okay, why is my patient not urinating? What's going on? And then look into all that kind of other things. So then you have the glomerular filtration. So filtration removes particles from a solution by allowing the solvent to pass across the barrier. So your kidneys are also the filtration system. So what happens is you got your glomerulus inside your kidneys, inside your nephron. So you got blood enters the glomerulus and flows through smaller and smaller vessels. So just like it's getting filtered. This increases the pressure within the vessels and forces a fluid out of the glomerulus into Bowman's capsule. So this fluid resembles plasma, but it contains no blood cells and almost no protein. So, and then it talks about the normal GFR rate, blah, blah, blah. So just know, like as things are getting filtered, it's a smaller and smaller and smaller thing to go through. So that way everything's just like getting squeezed out that needs to get out versus what doesn't need to get out. So then you have tubular reabsorption. Awesome. So key concept on page 321. Nephrons function to reabsorb and secrete various solutes. So you have ions, sodium, carbohydrates, glucose, and amino acids, glutamate. Know that. The key concept on page 321. And then you have what's called tubular secretion. This is the process by which substances move from blood into urine. The key concept just gets it down to the point. So tubular reabsorption, substance move from urine to blood, from that filtering out. And then tubular secretion is just the opposite, from blood to urine. So that's like everything that's like going through. Tubular reabsorption, back into the body. Secretion, getting out, secreting out. Okay, so as long as you understand those two differences, you'll be good. So, water reabsorption under the influence of ADH, antidiuretic hormone. So the secretion of the antidiuretic hormone depends on the amount of water in the blood. Awesome, antidiuretic hormone, break down the words and understand what's going on. So when it comes to urine production is influenced by, on the top of page 321, that key concept. Know the key concepts, I'm telling you. So urine production is influenced by kidney functioning, renal blood flow, hormonal balances, changes in the body's fluids and electrolyte status, salt intake, general physical condition, illnesses, exercise, and some medication. So a lot of things have a huge role in it, but as long as you're hydrated, your kidneys are pretty much going to function unless you have some underlying cause. Okay, so an NCLEX alert. Know the lab values. Know what's normal and know what's abnormal. It'll really, really help you. Okay, so characteristic and composition of urine. So what you need to know about this is the specific gravity. That's the lab value they use to measure urine. So the specific gravity of pure water is 1.000. Normal urine is only slightly concentrated with a specific gravity about 1.010 to 1.025. So a higher specific gravity indicates concentrated urine. So anything above 1.025 is dehydration. It's like that super gross, stinky yellow urine that's like dark yellow and you're like, dude, you need to drink some water. Versus below 1.010 is super hydrated. You're like, whoa, you're drinking a lot of water. You're like basically peeing water. So 1.03, dehydrated. 1.000, super hydrated. So just know like 30 is higher, dehydration, 1 to down, blah, 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 hydrated. How are you going to figure that out? Know that number. Test question. Okay, so normal urine is about 95% water and 5% solutes. So what are the solutes? The solutes include the nitrogenous waste products from breakdown of proteins. Common protein wastes are urea, uric acid, and creatinine. Excess minerals from the diet, such as sodium, potassium, chloride, calcium, sulfur, magnesium, ammonium, and phosphate. Toxins and certain drug metabolites. So certain drugs get metabolized with the kidneys. That's always a good thing to know when you have someone with kidney damage and you're giving them medications. Know kind of how they're being excreted through the body. Hormones, especially those related to person's sex, so except for the male sperm cells. And then you have pigments caused by certain foods or drugs may also appear, or urobilinogen. So certain medications will cause your urine to be a different color. And then depending on what you eat, sometimes beets turns your urine a little pink. So you have to just like, I was super surprised when I saw that. I was like, whoa, this beets. Anyways though, so 95% water, 5% solutes on the bottom of page 321. Okay, doing great. So a key concept, kidney transplants are the most frequently performed type of organ transplant. They were also the first organ transplant to be successful, with many recipients surviving 35 years or more. Awesome! Kind of a neat thing about kidney transplants. So again, you can live with a third of your nephrons working. Anyways, so when you do a kidney transplant, they leave your kidneys in there, and they simply take the transplant one and put it in there. I had no idea. This guy was like, yeah, I got like 3 or 4 kidneys in me. Actually, how many? I think he said 3. I think he would know for sure. I was like, wait, they don't take it out? He's like, no, they just put the new one right in there and they connect it to that one. I was like, wow. They probably do that to eliminate the amount of risk going on because of how vascular the kidney is. I don't really know why. I should probably look that up. But anyways, though, it's kind of cool. So some people could be walking around with like 6 kidneys and you wouldn't even know. Anyways, though, so micturition. That is basically another fancy way of saying peeing or voiding or micturition. So it's the involuntary micturition is called urinary incontinence. Sorry, ladies, when you have babies, if you don't practice those Kegels or whatever happens in life, it's gonna have a little bit of incontinence. So you gotta practice those Kegels. And your book has a great table on the effects of the aging on the urinary system. It is so important to understand the effects of aging because of our population, how the aging is just like getting older and older and older. So things that I want you to, like the big ones that I thought were really important were, so table 27.3 on page 322. So the blood flow to the kidney decreases, lessen urine formation. So watch their intake and output, super important. And they're gonna lose that thirst mechanism. They're not gonna be drinking, so that just promotes them to have more kidney damage from not being hydrated. Then you have the bladder lining may become fibrotic. So there's a decreased capacity of bladder. So normally your bladder is this full, there might be a little bit smaller, so they're just gonna have to have frequent visits to the bathroom. The client may have decreased ability to control the bladder contractions. That's when you're gonna have incontinence, unfortunately. So sometimes wearing just like extra pads. These poor little ladies, sometimes I have them wearing like, not only like the brief, but like 2 or 3 like big pads in there just in case they go to the bathroom, and I'm just like, oh, I'm so sorry. And then you have reduced bladder sensation, so they may not even know they have to go pee. And it's really frustrating, but then when that bladder is full, they can feel it. So, and then one more, and then I'm going to tell you a story. And then you have cancer or benign hypertrophy of the prostate is common in men. Definitely a big thing that, so the prostate for the men, so you have that 8-inch urethra, and the prostate basically is like a little like thing that goes right next to the urethra. And when this becomes bigger, it's going to squeeze on that little hose that you can pee out of. And it's going to be so frustrating for that guy because it's going to squeeze and he can pee a little bit. Then like 20 minutes later, he's going to have to pee again. And he's going to have to pee again. And he's going to have to pee again. And then when you're trying to do it fully, you're trying to get through this little tiny, so you have a nice hose all the way until that prostate is pressing on that urethra. It's terrible. So you have to get a special like Coude type Foley. And you can look them up. So look up Coude, C-O-U-D-E, I think. And then just a general Foley. There's a special tip in there, that like a special like formation to get through that little hose. So people might think, oh my gosh, gross, you're a nurse, like don't you like wipe butts and then like insert things into people's pee holes, like that's really gross. And I'm just like, you know what, if I think it's awesome. And the thing is, one time I had this old guy that really showed me like how important our job is. He could not pee for the life of him, and he was so uncomfortable. He was just like writhing in pain because it hurts. Hold your bladder for as long as you can. It is not fun. It's very painful. Anyways, though, I was like, hey, this is my plan of action. Let's get a Foley in you. Let's get you feeling better, and let's see what we can do. And we got like probably like 1,500 mils out, and he was just like, wow, thank you so much. And he was so nice to me. He's like, I really just want to like buy you dinner. I want to take you out with my wife. This is amazing. Thank you so much for helping me. And I was like, oh, blah, 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 blah. That's so nice. So anyways, though, it's what we do is pretty powerful. Even if it's simple things like that, it changes someone's entire day, someone's entire life sometimes. So keep up the good work. Anyways, that was a quick video on chapter 27. Read it. It's super quick. Everything you read is going to help you. Just kind of understand the anatomy of the kidneys, generally how they work, and then just know the functions of each little thing. If you know the key concepts and all the little nursing alerts, you'll be great. And then just know that understanding this effects of aging, it's really important when you have people go to the bathroom, especially the elderly. They're at risk for falling, they're at risk for incontinence, all this and all that. If you can understand that and you can make this best environment as possible while helping them encourage the drinking, it's going to really help them out. So, if you have any questions, you know how to get a hold of me. Anyways, that is that, and I'm going to work on a video for chapter 89. Thanks, guys.